Anyone?
Yeah, yes.
Oh, okay, fine. Yeah, thank you. Introduce myself. My name is Santanu Soe, and I'm a fourth year PhD scholar in the Department of Mathematics, IIT Madras, and my working area is convex optimization. And those guys who, I mean, those who know optimization might know a bit about convex optimization, but I'm not gonna go on to the details. But I'll be TA for this course, multivariable calculus, which is currently taken by two professors from IIT Roorkee. And yeah, so this is week one. So yeah, this is week one. And before each season, like before starting of each class, I'm gonna give some summary of that week, like what they have done in the week, and then we'll be solving some questions, and that will be helpful to solve that same week's assignment. So I think in this first week, they have taught about limit, continuity, and partial derivatives. Now, if you have any questions at any point, you can ask me always. So this is kind of an interactive season. So you can ask me anytime any questions. Okay, during this season, this 2 hour season. So do not hesitate to ask any question. So first is the definition of limit. Now, for one variable function, especially those guys who have done bachelors, so you have seen that the definition of function, the limit, like the definition of limit of a function is pretty clear. For example, if we say that limit extends to a, f of x equals to L, so that means if there is a function y equals to f of x, and you approach the point A, suppose this is a comma 0, and you approach the point A from the left side or right side, and if the limit are equal, the like the right hand limit and left hand right limit are equal, then this limit is called the limit of the function. But the definition of limit for two variable is different, because in this case the function is from R to R, right? But in case of two variable, the function is from R to R. So that means there are two arguments. So now the definition is kind of like this, that limit x comma y tends to a comma b, f of x comma y equals to L, right? And the epsilon delta definition of one variable was like this, that given an epsilon greater than 0, there exists delta greater than 0, such that fx minus L less than epsilon whenever modulus of x minus a is less than delta, right? So given an epsilon greater than 0, whenever the values of x and a will be less than delta, the corresponding functional value and the limit, like the distance between the functional value and the limit, will be also less than epsilon. So this can be explained through a graph also. For example, if this is a function, right, and this is the point A, so then the interval a minus delta, and this will be a plus delta for any delta greater than 0. And if this is the limit L, then this will be L plus epsilon, and this will be kind of L minus epsilon. Okay, so this will be L minus epsilon, and this is the limit actually L. So now it says that if you take values, now it says that if you take any values of x between this interval, then the functional value will be coming into this interval, right? So that means if you take x belongs to a minus delta, comma a plus delta, this will imply that fx will lie also in this interval, L minus epsilon to L minus L plus epsilon. So this is the definition, whatever we have learned in our bachelor's, right? So this is the one variable definition, right? So this also can be written like this, that f of a minus delta comma a plus delta will be subset of L minus epsilon comma L plus epsilon. So this is called the one variable limit. Now for two variable limit, there are two arguments, right? So then you cannot use simply modulus. So you have to use a different argument. So this is will be like, I mean, the modulus will be changed by a norm, right? So that means if so that means if we say that limit x comma y tends to a comma b, f of x comma y is L. So that means if you take a neighborhood of like I say circular neighborhood, for example, this one, then given an epsilon greater than 0, you can find a delta greater than 0 such that whenever this holds, this will imply that the functional value minus of the limit is always less than epsilon. Now this is also same as whenever you can write, I mean, for example, you can write that modulus of f of x comma y minus L is less than epsilon whenever 0 less than x minus a whole square plus y minus b whole square is less than delta. So this definition is also valid. So now we're gonna solve some questions from limit, and then we're gonna go to partial derivatives and then continuity as well. Now before that, I'll be solving some questions regarding open set and closed set. I think these things we all have studied in our bachelor's program or in the first years of bachelor's program. Now, for example, this question is given. Uh, like examine the set, examine the following set. So first one is S1 equals to x comma y in R2 such that x plus 4y is less than 3. And second question is this one, x comma y in R2 such that x square plus y square equals to 1. Okay. So now for this two following set, we have to ask the question that which of the following set is open and closed. So that means, yeah. So we have to find out that S1 is open or closed, S2 is open and closed, and so on. So yeah. So let us come to the first question, that is S1. So S1 is nothing but so yeah. So S1 is nothing but a straight line, right? So for example, if this is the R2 plane, then x plus 4y equals to 3 is nothing but x by 3 plus 4y by 3 equals to 1, right? So that means the intersecting point are 3 comma 0 and 0 comma 3 by 4, right? So this will be around 3 comma 0 and this will be around 3 by 4. So this will be like this. So this is the straight line. So now they are asking all of points x comma y in R2 such that x plus 4y is less than 3. So since the points are like less than 3, so for example, this origin belongs to this point, this set S1, because if you put 0 plus 4 into 0, then it will be 0 and ultimately it will be less than 3, right? So that means the set belongs to this region. Yeah. So now can anyone guess which set it will be? Like it will be open or closed? Anyone? Anyone from the audience can guess, is it open or closed? Anyone from the audience? Okay. So clearly this set is not open, right? I mean S is not a closed set because a set is closed if it contains all its interior points, right? Because if you take the set R2 minus S1, then this will be nothing but all of x comma y in R2 such that uh, x plus 4y is get equals to 2, and this set will be a closed set. So, and then complement of a closed set is an open set. So this set will be an open set, right? Because it contains all the interior points. So whatever points you take in this region, so for example, if you take a point here and you take a neighborhood, then this point will be, I mean, this the neighborhood containing the point will be always belong to the set S1. So that's why this set S1 is closed, because all the interior point of S1 belongs to S1, correct? So this set is an open set, not closed, because its complement is closed. So that's why it is open. Okay. Now what about the set S2? So, so S2 is nothing but a circle, right? A unit circle. Okay. So now this circle looks like this. So the center at the point 0, 0 and radius at 1, 0. So the radius R is 1 and the center is 0, 0. So now this set is not open clearly, because if the set is open, then all the point, I mean all the interior point, I mean all the points should be an interior point. So for example here, this point, so this point lies on the circle, right? This point lies on the circle. But if you take a circular neighborhood here, then this the other points like belonging this region, this empty region, does not belongs to S2, right? So that means S2 is clearly not an open set. Clearly not an open set. Now, what is the guarantee that S2 is a closed set, right? I mean, open does not necessarily imply that it will be a closed set. So, to prove S2 is a closed set, you can use a famous theorem from real analysis that if f is a function from Rn to R such that f is continuous, then inverse image of closed set is closed. Now, this is a very strong theorem, not only true for closed set, but it is true for open set as well. So this is kind of a theorem. So that says that if is a continuous function from Rn to R, then the inverse image of a closed set will be closed set. Now, how we can use this theorem? So just see that we can define a function from R to R such that f of x comma y equals to x square plus y square. Now, since this function is a polynomial, right? Because x square plus y square is a polynomial function. It's a sum of two differentiable functions. So it's a continuous function. I mean, in one variable, not in two variable. Just thinks as a one variable. So this is a one variable function. This is a one variable function. So sum is a one variable function. So it's a continuous function. And the inverse image of one is nothing but S1. Now, how this holds? So inverse image of one is nothing but those points x and y in R2 such that f of x comma y is 1, correct? So those points x comma y in R2 such that x square plus y square equals to 1. So now we all know that the singleton 1 is a closed set in R, correct? So by the above theorem, it will imply that f inverse of 1 will be a closed set. So this will imply that S1 is a closed set, because f inverse of 1 is nothing but S1. So S1 is a closed set. Okay. So yeah, is it clear so far? If there is any question, you guys can ask me always. Yeah. So in this question, is there any doubt? Anyone? Okay, fine. So yeah. Okay, so now I'm going to go to the next question, which is to find out the limit of a function of two variables. So this is question number 2. Now the function is given like this. Let f of x comma y equals to 3xy divided by x square plus y square when x comma y is not equals to 0 comma 0, and 0 when x comma y is 0 comma 0. Okay, so now one thing to notice here is that since it's a two variable function, there is no such particular direction where you can check the limit if the limit exists or not. Now what is mean by that? Now for example, in one dimension, I mean in R, sorry. So in R, for example, if you want to check the limit of a function f of x at the point A, so then you have two options. Either you go from right or you go from left, right? So that means you can either compute limit extends to a minus f of x or limit extends to a plus f of x. But in case of two dimension, you can approach a point from various directions. So for example, if this is a point a comma b, you can approach from here, you can approach from here, someone can approach from here, and someone can approach from here as well, right? So that means there are infinitely many directions through which you can approach the point a comma b, and through which different values or different limit values can come, right? So that means to check if the limit exists, we have to go through the definition of the limit of a function. And to disprove that the limit does not exist, if you can find two directions where the limit is not equal, then we can guarantee say that the limit does not exist. So for example, if you find a direction uh, from suppose if you find a direction from here such that the limit is L1, and you find a direction from here that such that the limit is L2 and L1 is not equals to L2, then you can definitely say that the limit of the function at that particular point a comma b does not exist. So that's what we're gonna do here. So yeah, so now try to check that. Okay, so so first let us go through the direction y equals to 0. Okay, so here you check that if you just put y equals to 0, then f of x comma 0 is nothing but 3 into 0 by x square, which is 3 by x square, correct? I mean 3x by x square, right? Yeah, so this is 3 into 0 by x square, so this will be 0. And similarly, if you take this line, that line y equals to x, then f of x comma x is nothing but 3 into x divided by x square plus x square, so which is nothing but 3x square divided by 2x square, and this is nothing but 3 by 2. So now we can see that if we take limit x comma y tends to 0 comma 0 along this line y equals to 0, the limit is 0. And if you take along this line, then the limit is nothing but 3 by 2. So now if we call this as L1 and if we call this as L2, then we can clearly say that along two different paths, L1 is not equals to L2. So that means we can say that this limit does not exist because we have found at least two paths along which the limit is different. Now in general, you can take y equals to m of x, where m is a non-zero, or maybe m is a real number, doesn't matter. Then you can substitute this value f of x comma m of x. So this will be nothing but 3 into x into mx divided by x square plus mx whole square. So now notice one thing here, that x comma y should tends to 0 comma 0, doesn't matter whatever path you take along your limit. So because here if x tends to 0, then y equals to m of x will also tends to 0. So that means both the limit x and y should tends to 0 because x and y are tending to 0. So now here we can check that this is 3m x square divided by x square plus m square x square, and this is nothing but 3m divided by 1 plus m square. So now if you take limit x tends to 0, then this is equals to nothing but limit xy tends to 0 comma 0 f of x comma y. Correct. So this is nothing but 3m by 1 plus m square. So now if you vary the values of m, for example, if you take m equals to 1, this limit will be 3 by 2. That's what we have taken before, right? We have chosen the path y equals to x, so that's why it corresponds to the value 3 by 2. Now if you take m equals to 2, so this will give you the limit as 6 divided by 5. So that means for different values of m, you are getting different limit values, and that should not happen. If the limit exists, it should be always equal, through different direction. So that means in this case, we can definitely say that this limit of x comma y tends to 0 comma 0 f of x comma y does not exist. DNE stands for does not exist. Yeah. So now is there any doubt so far? You guys can tell me, and you guys can unmute anytime and just ask me any questions. Any question. It can be a silly question, doesn't matter. Okay. Yeah. Anyone? Is there any question?
Sir, can you explain question one more time, please?
Yeah, sure. Okay. So you see, so they have asked the question that if the limit of this function f of x comma y equals to 3xy divided by x square plus y square exists or not. Now to check that the limit exists or not, first we have to make a case. You cannot just certainly go for epsilon and delta definition, right? Because you see here the dimensions are matching here. So for example, in the numerator there is 3xy. So that means the powers are nothing but something like 1 plus 1 2. Here also its power is something like 1 plus 1 2. So that means we can try to think that if you just can like eliminate the dimension of both x and y, then the limit of the function can be independent of x and y. So that means in that case we can show that the limit does not exist. So that's why first we choose two different paths. So first we choose the part y equals to 0. So in that case, if you just put y equals to 0 here, because x is non-zero, x can be taken any value. So then you can see that this is nothing but 3 into x into 0 divided by x square, because y is 0. So this is nothing but 3 into 0 by x square, which is 0. So that means you can directly write 0 here. And if you choose the path y equals to x, then this will be nothing but 3 into x divided by x square plus x square, right? So then you are getting 3 by 2. So that means along two different paths, you get two different limit. And that should not happen. If the limit exists, it should be equal for every path possible in every direction. Since we got two direction where the limit does not exist, I mean limit exists but they are not equal, so we can say that the limit does not exist at 0, 0. Now to show in general, I showed you that you can take various directions such as y equals to m of x. You don't need to necessarily take y equals to x. You can take the direction y equals to 2x, 3x, 4x, and so on. So that's why I just substituted y equals to m of x here. So it will be nothing but 3 into x into m of x, and this will be divided by x square plus m of x whole square. So then x square will get cancelled out. So this function f of x comma m of x is changed into 3m into 1 plus m square, right? This one. So now since we have substituted the value of y, which is m of x, then this limit is changed into this limit. And this is nothing but like from here, this is 3m divided by 1 plus m square. So that means the limit is depending on various values of m. So you change the values of m, the limit will be getting different values. So that means the limit is not equal in this case. So we can say that the limit does not exist. Yeah, please.
Uh, सर
Yeah.
एवरी आपने सिर्फ y के वैल्यू को लिया है मैं x के वैल्यू को भी तो ले सकता हूँ चेंज करके जैसे यू टुक y बराबर समथिंग y is equal to
Yes,
0
yes, yes. Whatever doesn't matter. No, if you take y equals to x, then it is same as you are taking x equals to y, right?
yes sir
Correct. So you have to you have to be very clever in this way, right? You have to be very clever in such a way that the tending limit should be tends to 0 because you need x comma y tends to 0 comma 0. So for example, you can ask me the question why you are not taking y equals to x plus 1. Right, this you can ask me the question because I am not taking y equals to x plus 1 because if x tends to 0 then y will tends to 1. Then the limit x comma y will tends to 0 comma 1 instead of 0 comma 0. And this we do not want because in the question they have asked that if the limit exists at 0 comma 0 or not. Correct. That's why I
Yes,
have
sir.
chosen the path y equals to x, not x plus 1 or something like mx plus 1. Yeah.
Okay, okay.
Yeah. I hope that is clear.
What is a closed set, sir?
So a closed set means if it's contain all its limit point, then it's a closed set. Or if it's not an open set, I mean the complement, I mean the, for example, if C is an open set, then R minus C is a closed set. Yeah. So I recommend you to read this book, SK Mappa. This is my personal recommendation. And also you can read Bartlett Herbert book.
Sir, can you repeat the book one more time? First book.
First book is SK Mappa. You can see here in the on the screen, right? SK Mappa. It is available, I think. I mean, you can buy also. I don't know, but yeah, this is a very nice book to start with.
Sir, I can't understand the first question clearly, sir. Can you explain one more time?
First question. Which one? This one?
Yes, sir.
Okay. So yeah, I mean, a set is called open if its content, I mean, if it's all point is an interior point. So interior point means if you take a point and then you take a neighborhood, then this neighborhood will belong to the like the same set again. So then the point is called an interior point. Now here I'm making an observation that the set S1 is nothing but the inside of this line x plus 4y equals to 3. So this is the line nothing but x plus 4y equals to 3. So since we need point which is x plus 4y less than 3, so that means this will be the region. Correct. For example, you take the point 0 comma 0 that is belonging to this region S1. So now I'm saying that if you take a points inside of this region and then you take a circle, no matter how small it is, I mean, you can choose alongside. So then this circle will be always belonging to the region S1. So that means for every point on the region S1, you can find a small circle such that that will also belong to this circle, I mean the region S1. So that's why S1 is an open set because every point is an interior point.
Understood, sir.
Okay, so you go through the book. I recommend everyone to go through the book SK Mappa. This is my personal recommendation. Okay, so yeah, so now we're gonna go to the next question. So yeah, let us see a interesting question, maybe. Okay, okay, yeah. So next question is, so let f of x comma y equals to x square y plus 4x y square divided by x square plus y square when xy is non-zero and 0 when xy is sorry 0 comma 0. So now find out conditions on S for which modulus of fxy minus f of 0 comma 0 is less than 0.1 whenever 0 less than square root of x square plus y square less than delta. Yeah. So yeah, can anyone tell me the answer if you guys know? Yeah, anyone? Okay, so first of all here they have given us the epsilon, which is nothing but 0, 1, correct? And they are asking us to find the delta in terms of epsilon. So that means we have to find the values of delta for which this relation hold. This relation, for example, this one holds. So now we can just substitute the value of the function f of x comma y. So here you can see that this is nothing but, I mean, f of 0, 0 is nothing but 0 because of this, correct? So now we can just substitute this f of x comma y, which is nothing but x square y plus 4x y square divided by x square plus y square, and this should be less than 0, 0.1. So now, so from here, try to see that modulus of x square y plus 4x y square divided by x square plus y square, this is less equals to modulus of x square y divided by x square plus y square plus 4xy square divided by x square plus y square, right? So this is nothing but x square divided by x square plus y square into mod y plus 4 times mod x into y square by x square plus y square, right? So now how many of you can see that mod x is less equals to, sorry, x square is less equals to x square plus y square. Okay, so let me write here. Yeah, so x square is less equals to x square plus y square, and y square is also less equals to x square plus y square, right? So by these two result, we can say this is less equals to mod x plus, sorry, mod y plus 4 mod x, right? So now another observation we have to make from here is that mod x is less equals to square root of x square plus y square, and mod y is also less equals to x square plus y square, square root of x square plus y square. So this will be nothing but square root of x square plus y square plus 4 times square root of x square plus y square. So this is nothing but 5 times square root of x square plus y square, right? So now they have asked us the question that when this will be less than 0.1, correct? So this is implying that square root of x square plus y square is less than 0.1 divided by 5. So what is 0.1 divided by 5? So this is nothing but 1 by 10 into 5. So this will be 0.02, right? So that means our delta should be at least less equals to 0.02. Now, for example, if you just take delta equals to 0.02, then this relation will hold, this relation 1. So the answer is nothing but 0.02. Yeah. Is it clear for anyone? I mean, for everyone? Or is there any doubt? This is very simple, right?
Sir,
Yeah.
can you explain the step from after the step root x square plus y square plus 4 root x square plus y square after that, from after that?
Okay. So then the sum is nothing but 5 times square root of x square plus y square, right? And then they have asked the question that when f of x comma y minus f of 0 comma 0 is less than 0.1, and then you find out the values of delta such that modulus of square root of, I mean, square root of x square plus y square is less than delta. So now you just make it less than 0.1 because that's what we are doing here, right? We are just calculating this one, f of x comma y minus f of 0 comma 0. Now we have to show that this is less than 0.1. Now, since we find out that this is nothing but less equals to 5 times x square plus y square. Now we have to show this is less than 0.1, right? Now, if this is less than 0.1 implies square root of x square plus y square is less than 0.1 by 5. And this is nothing but 0.02. And this is what you want, right? This is nothing but our delta, correct? Is it clear?
Yes, sir. Yes, sir.
Yeah. So this is just you are replacing 0.02 by delta because this is what you all want, right? Because we just want this one, x square plus y square less than delta. That's all.
Sir, one thing is not clear. Can you scroll up, please?
Yeah, sure. Yeah, my handwriting is a little bit bad. I'm sorry for that. But yeah, you can
No,
ask
not
me
the
anytime.
understood.
Yeah.
Sir, how can you write f of x comma y minus f 0 comma 0? How can you write that?
Sorry, which one?
How did you use the formula f of x comma y minus f of 0 comma 0?
Yeah, because f of 0 comma 0 is 0, right? And f of x comma y is already given, right?
Understood, sir. Yes.
Okay, yeah. So yeah, is there any questions from other people? Okay, if not, then we'll go to the next question. Okay, so okay, yeah, next question. So let f of x comma y equals to y cos 1 by x whenever x and y are non-zero, and 0 whenever x and y are 0 comma 0. So now if you guys are preparing for like IIT JAM exams, so this course will be, I think, very helpful. I mean, very, very helpful to solve questions in IIT JAM. Especially this type of questions will be asked in the this kind of similar questions will be asked in the exam. So it will be very helpful, I think, to attend this course. So yeah. And also in the meantime, I'll be solving some questions from IIT JAM, like previous year's questions. Okay, so that you guys can relate what type of questions are coming in the exam. Okay, so yeah, so the question is examine the existence of limit x comma y tends to 0 comma 0 f of x comma y limit sorry limit x tends to 0 limit y tends to 0 sorry f of x comma y and then limit y tends to 0 limit x tends to 0 f of x comma y. Okay, yeah, fine. So now this is a very famous function. I don't know if you guys have seen or not, like x cos 1 by x, x sin 1 by x. And this kind of functions are very similar, but here x is nothing but replaced by y. So yeah, this is a three-dimensional function. I mean, you cannot plot this function in two dimension. Okay, so yeah, any case how to do this? I mean, like for example, first we have to show that this limit exists or not. Yeah, anyone? Any guess? Okay, so yeah, I'm gonna start. Yeah, tell me.
हाँ सर, पिछले के जैसे y को x लेके इस तरह से y इक्वल टू x.
Okay, so that you can do only when the limit does not exist. If the limit exists, then you can.
Sir,
Yeah, hello.
हाँ या
Yeah, so if the limit exists, then you have to prove using the epsilon and delta definition.
ओके.
sir, hello?
Yeah, tell me.
Sir, we should take mod f of x minus L, which is less than epsilon, and later we need to substitute the value which is less than s. What is that? Lambda value.
Yes. That is correct. That is correct. Yeah,
Yeah.
that's the correct approach.
Then we should relate with it, and we should say which is greater than or equal to something in s.
Yeah, that's true. That's true. So yeah, so what we're gonna do is we have to show that given an epsilon greater than 0, there exists delta greater than 0 such that this one this one will be so in this case I'm assuming the limit to be 0 less than epsilon whenever uh, x square plus y square is or square root of x square plus y square is less than delta. So here we have to just find out the delta in terms of epsilon. That's all. So we're gonna start from here, correct? So what is f of x comma y? So f of x comma y is nothing but y cos 1 by x. So this is y cos 1 by x minus 0. So this will be nothing but modulus of y modulus of cos 1 by x, right? Now we all know that modulus of cos 1 by x is less equals to 1 and mod y is less equals to square root of x square plus y square, right? So this will be less equals to x square plus y square. Now we need this to be less equals to epsilon, correct? So that means if you just take delta equals to epsilon, then modulus of y cos 1 by x minus 0 will be less equals to x square plus y square less equals to epsilon, and also square root of x square plus y square less equals to delta. It doesn't matter. Less equals to strictly less than, both are same, because you can always take sufficiently small epsilon or epsilon delta. So yeah, so in this case our delta is nothing but same as epsilon. So if you just choose delta equals to epsilon, then you can show that this limit exists and it's equals to 0, correct? Yeah. So is it clear? And this limit is nothing but this one. This is the limit. Okay. Is there any question? Anyone? You can ask me always any questions. It can be silly, it doesn't matter.
So one doubt is there.
Yeah.
Uh, so in say few books, so the condition that you have taken for delta, like that is square root of x square plus y square less than delta. So in few books, I have seen like there are like different condition for x, like mod of x less than delta and mod of y less than delta. Like they used to take two different conditions of x and y
Yes.
for delta, and or so those methods, like both these methods are okay or fine to
Uh,
work on.
yeah. This is a very nice question. Yeah. What's your name? Sandeep. Yeah. This is a very nice question. So I think I'm going to explain here. So basically, what we are doing here is this is a point a comma b, correct? So now I cannot draw three-dimensional function easily, but I can show you why we generally choose this circular neighborhood, right? Because this is nothing but x square plus y square is less equals to delta square, right? So now some book can take different type of neighborhoods. Even you can invent your new method for giving the different definition of continuity. You can ask me why you are not taking this neighborhood. This is also valid. Okay. So as a mathematician, I can tell you that this neighborhood is also valid. So now if you say this neighborhood is n delta of a comma b, and if you say that n delta of a comma b whenever x comma y belongs to this point and implies f of x comma y minus 0 less than epsilon, then this is also a valid definition of continuity at the point 0 comma 0. Okay, but the problem is why we do it, like why we do take this type of interval, I mean this type of neighborhood, because circular neighborhood are always easy to take, always easy to understand, right? For example, if you take a neighborhood like this, we can always find a small circular neighborhood that will also satisfy the same requirement. So that's why some book can take mod x less equals to delta, 0 less than mod y less than delta. So this is nothing but what? This is nothing but a rectangular neighborhood, right? Or maybe a square neighborhood, right? So this is the point a comma b. But it doesn't matter because you can always take a circular neighborhood inside that square or rectangle. So that's why the easy thing to take is nothing but the circular neighborhood, because whatever neighborhood you choose, I can always find out a smaller circular neighborhood inside this region. So that's why the standard thing is to take this neighborhood.
Uh, say say by choosing two different options for delta,
Yeah.
our value of like epsilon might change in answer. So that
No, no, delta depends on epsilon, right? So epsilon will not change. Epsilon is fixed. Delta might change depend on the neighborhood.
say for this example, say we have chosen as square root of x square plus y square less than delta. Say
Yes.
if I'm choosing mod of x less than delta individually and mod of y less than delta individually, then I have to put, say, if after that, if I get the condition of square root of x square plus y square, and then I put delta square per delta square plus delta square inside in that last condition, then I will get square root 2 delta equal to
Yes,
epsilon.
yes, yes,
But
yes.
here you have
But that's okay
got epsilon is
because
equal to
because I have chosen different neighborhood. But if you, for example, this is a very nice question. So for example, if you take mod x less equals to delta and mod y less equals to delta, then here you also get square root of sorry, this is will be less than epsilon, correct? So in this case, what do you get? So you will get modulus of square root of 2 into delta less equals to epsilon, right? So if you just take delta to be less equals to epsilon by root 2, then there your definition is valid. So in this case, just delta is different, but the definition is still correct. So it depends on what neighborhood you choose. If you choose the rectangular neighborhood, the delta will be different sometimes. And if you choose the circular neighborhood, then obviously delta will be the thing what I've just shown. This is also
okay. So
clearly valid.
so in some questions, sorry, sir, you were
Yeah.
saying something.
No,
Sorry.
no, no, you tell me. Yeah.
So in some question, like they used to provide the value of say epsilon, and they want an what you can say, the corresponding value of delta.
Yeah.
So if I'm choosing the mod x mod y option, my the value of delta that will be obtained will be different if I go via the circular one.
Uh,
So
yeah.
that will be
So
considered as wrong, or
no, it is not definitely wrong. But if in the question, if they ask you that find this epsilon greater than 0, where they have given, I mean, they have given suppose epsilon greater than 0 like this, and they have asked you to find delta such that this holds, then only you cannot do using your the method you are saying like the rectangular neighborhood, because they have specifically given that you have to choose the circular neighborhood. In that case, if you found
oh,
like if you find that delta equals to epsilon by root 2, then it will be wrong.
okay, okay,
So it depends on the question. If they ask you like this neighborhood, then you cannot go through any other neighborhood. And if they do not ask you any other neighborhood, then you can go through any neighborhood. Doesn't matter. It should be always right. That I can guarantee you.
okay, okay. Thank you.
Yeah. Okay. Fine. Yeah. This is very confusing sometimes. I know, but yeah, it doesn't depends on the neighborhood, because since circular neighborhoods are always easier, that's why you choose circular neighborhoods always. So that's why sometimes I've
So
also,
one
yeah. Tell me.
based on the question, like in some condition, like it's easier to use like x minus a square plus y minus b square square root of that condition, and in some questions it's quite easier to use the mod x mod y option. So if we have to just prove that whether limit exists or not, we can use any option which like suits or which seems simple, then that should work, I guess, right?
Yeah, whatever method you apply. So basically, it depends on the problem. So in some problems, circular neighborhood will be easier to find out, and for some problem, it will be easier to take like square or rectangular neighborhood. So it depends on the problem actually.
Got it.
Okay. Yeah. So okay. So yeah, we have to. The next question is this limit exist? Limit x tends to 0. Limit y tends to 0. F of x comma y. Right. So now here we can see that so these are called the separated limit. So here f of x comma y is y cos 1 by x, right? So I'm writing the function here again. Okay, yeah. So now can anyone tell me uh, what is the limit in this case? Any guess? Anyone? So you guys all should participate. Okay, this is just like an interactive session. So that's why you guys can learn something. It can be silly. I'm always saying it can be a silly question. Doesn't matter, but you have to speak out. Yeah. Any guess? Okay. So now try to see that.
Oh,
Yeah. Yeah. Please tell me.
if double limit exists, then irritated limit as well exists.
If the double limit exists, then
Then the some irritated limit as well exists.
are you sure?
Yeah, sir.
Okay. So let us see.
No, sir. It's vice versa. If
Okay.
it's
Okay.
vice
Okay.
versa.
Okay. We'll see. Okay.
Hmm.
Okay. Yeah. So limit. So first you have to calculate this limit. Then you have to calculate this limit, right? So now we can see that limit y tends to 0, f of x comma y is nothing but limit y tends to 0, y cos 1 by x. So now see this x as a constant because here x doesn't have a value. Here x is not a variable. So see this cos of 1 by x as a constant. Now as y tends to 0, this limit is 0. Correct. So that means this is nothing but limit x tends to 0 into 0. So this is 0. Correct. What about this limit? Limit y tends to 0, sorry, limit x tends to 0, f of x comma y. So now try to see here that this is nothing but, so first we have to show that what is the limit of this f of x comma y. So this is limit x tends to 0, y cos 1 by x. So now how many of you can see that this limit does not exist? Does this limit exist? Anyone? Okay, so I think you guys know that this limit does not exist, right? Correct. Okay, so yeah, take this as an exercise for you guys I'm giving, that this limit does not exist because this is nothing but same as cos 1 by x. So now you can show that this limit does not exist. So what are you gonna do? You're gonna choose two different sequences through which you can evaluate the limit, and you see that two different limit will come. So that means you can say that the limit does not exist. Okay. So yeah, this is as an exercise. Maybe I can give some hints. So you choose the first sequence as 1 by n pi by 2, and the second sequence you choose as 1 by 2n plus 1 into pi by 2. So now if you choose these two sequence and then tends the limit n tends to infinity, then you can see that the different type of limit will come, varying the values of n. So then we can say that the limit does not exist. So in general, if the limit exists, that doesn't necessarily mean that both the separated limit will exist. Okay. Now there is a theorem for that. I'm gonna write those theorem. Then only we can say that. Okay. So yeah, probably I'm gonna write the theorem. So the theorem is, so if limit x comma y tends to a comma b, f of x comma y exists, then the separated limits, limit x tends to a f of x, sorry, limit y tends to be f of x comma y equals to limit y tends to be limit x tends to a f of x comma y provided that limit x tends to a f of x comma y, sorry, and limit y tends to be f of x comma y exist. So this is a theorem which says that it will be like the separated limit will exist and be equal if the main limit exists, the double limit exists, and the particular limit, I mean the separated limit at x tends to a and y tends to b both exist. Then the two separated limit will be equal. Example, I show that this limit is 0 and this limit is also 0, but this limit does not exist. Correct? So, but okay, so I'm gonna go to the partial derivative section. Okay, so what is partial derivative? Anyone? I think in this week partial derivative was also taught. Now, partial derivatives. So yeah, so I think in this week we have seen two type of partial derivative. One is partial derivative with respect to x, and another is with partial derivative with respect to y. Right. So we have seen fx a comma b and fy a comma b. Okay. So fx a comma b is nothing but, so this definition is nothing but limit h tends to 0 f of a plus h comma b minus f of a comma b divided by h. Correct? Okay. Just let me check one thing. Okay. And this definition is nothing but limit h tends to 0 f of a comma b plus h minus f of a comma b divided by h. Okay. So these are the two definition of partial derivative with respect to x and with respect to y. So now we're gonna see some question and we'll solve some questions for that. So is there any doubt regarding partial derivative? Anyone? So have you guys seen the videos which have been shared for week 1? Okay. So yeah. So the first question is find out fx of 0 comma 0. Okay. Okay, maybe I'll write the question.
Sir, I had seen it long time ago, but not recently.
Okay, it's okay. So let f of x comma y is xq minus xy square divided by x square plus y square, where x comma y is non-zero and 0 when x comma y is 0 comma 0. So now you have to find out what is fx 0 comma 0 and fy 0 comma 0. Okay, so this is just basic formula. You just put in the limit formula and find out the limit. That's all. So what is f of x comma 0 comma 0? So this is limit h tends to 0 f of, so here a is nothing but 0, b is nothing but 0. So it will be f of 0 plus h comma 0 minus f of 0 comma 0 divided by h. So this will be limit h tends to 0, and this is nothing but f of h comma 0 minus f of 0 comma 0 divided by h, right? So this is limit h tends to 0. Now what is f of h comma 0? So see here that when x and y both are non-zero, then this is the function value, right? So this will be nothing but hq minus h into 0 divided by h square plus 0 square and f of 0 comma 0 is 0 divided by h. So this will be limit h tends to 0, and this will be h divided by h, right? Because this will be h cube divided by h square by h, right? So this is nothing but 1. So if x at 0 comma 0 is 1. Okay. So next is fy of 0 comma 0. So this is limit h tends to 0, f of 0 comma 0 plus h minus f of 0 comma 0 divided by h. So this is limit h tends to 0. Now what is f of 0 comma h? So now here also we can see that when xy is non-zero, f of x comma y is nothing but x cube minus xy square divided by x square plus y square. Correct? So this will be limit h tends to 0, and f of 0 comma h will be, so this term will be 0, and this term will be 0 into h, so this is 0, and divided by 0 square plus h square. So this is 0 minus 0 divided by 0 square plus h square. So this is nothing but 0. So here fy of 0 comma 0 is 0. So yeah, is it clear for everyone, or have I gone through very fast? I mean, I don't know.
Sir, can you explain from limit h tending to 0, 0 minus 0 upon 0 square plus h square? The second part.
Second part here, this one,
Yes, sir.
yeah, this is 0, right? So basically I have just plotted the value of f of 0 comma h and f of 0 comma 0. So f of 0 comma 0 is 0, right? Because you see when xy is 0 comma 0, this is 0, and when xy is non-zero, this is the value. So here x will be h and y will be 0. So you put all the value. So here, for example, if you put x equals to h, this will be h cube minus 0 into h square divided by 0 square plus h square. So this will be what? This will be, sorry, this will be 0. So this will be 0 minus 0 divided by h square. So this is 0. That's what I have written here, right? 0 minus 0 divided by 0 square plus h square, and this is 0.
Sir,
Sir,
H
understood.
what, sir?
Yeah, tell me. Hello.
Sir, H denote what? What does H denotes?
What h denotes?
Yes, sir.
Yeah, h is a very small number that tends to 0. So for example, uh, what is the usual limit in case of function from R to R? So what is the derivative at the point a belongs to R? So this is nothing but limit x tends to a, f of x minus f of a divided by x minus a, right? So now this definition can be changed using taking x minus a equals to h, right? So this implies x equals to a plus h. So this is just for one dimension. So now as x tends to a, this h will tends to 0, right? Because if you just put x equals to a here, this will imply h equals to 0. But you cannot directly put h equals to 0, right? Because h is in the denominator. So we just say that if x is approaching a, h will approach 0. Correct? So
Okay.
because so from here, this is h tends to 0. Now what is x? X is a plus h. A plus h. So this will be f of a plus h minus f of a, and x minus a is nothing but h. So this is h. So that's how the definition comes in one variable. Similarly, you can do for two variable also.
Okay.
Yeah. Okay. So okay, maybe I'm gonna go to the next question. Okay, so yeah. So this is question number what? It doesn't matter. Let me just write here. So let me write just question number 1 here. So yeah, find the slope of fxy equals to x cube y plus x square y square in the x direction as well as y direction at the point 2 comma 1, right? So now one thing to notice here is that this f of x is comma a comma b is nothing but the partial derivative with respect to x, and then you put the point a comma b, right? So now if you know this limit exists, I mean the partial derivative exists, then instead of doing this limit thing, you can just simply do the derivative and putting the other variable constant. So for example here, so here f of x comma y is nothing but x cube y plus x square y square, and they have asked in the question to find the values of fx comma 2 comma 1 and fy of 2 comma 1, correct? So these two we have to find out. So now since this function is differentiable, because I'm not going into differentiability right now, but from here we can see that this is a polynomial function, so both the partial derivative will exist. So that's why we are assuming that partial derivative exists. Otherwise you can also go through the definition of this limit definition. So that means you can just find out like this also. Limit h tends to 0, f of 2 plus h comma 1 minus f of 2 comma 1 divided by h. So this definition also you can use, but since this is a polynomial function, I'm going to use the simple differentiation definition. So this will be nothing but 3x square y plus 6x, sorry, 2x y square, correct? Because I'm just putting y to be a constant since we are doing derivative with respect to x, and then you just put the values of 2 comma 1. So this will be 3 into 2 square into 1 plus 2 into 2 into 1 square. So this is what? This is 12 plus 4, 16. So if x at 2 comma 1 is 16. So similarly, you can find out del f del y. So this is nothing but just putting x as a constant and then doing derivative with respect to y. So this will be x cube plus 2x square y, correct? And then you just substitute the value of x comma y. So this will be 2 cube plus 2 into 2 square into 1. So this will be 8, and this will be also 8. So this is 16. So in both cases, uh, the partial derivative with respect to x and y at the point 2 comma 1 is 16. Okay. Is there any doubt in this question? Anyone? You can ask me. It can be a silly question. Doesn't matter. You can always ask me.
Sir, first we have to prove if it exists, and then we can do the rest of the part. Am I
Yes,
right?
that's true. That's true. That's true. But since this is a polynomial function, right? You can just see that the limit will exist. I mean, because this is just a differential function, so this will come in the due course, the differentiability. But since I can see that limit exists, because you just go through this definition, and you will also get the answer to be 16. But it will be like slightly lengthy. The calculation will be slightly lengthy. That's all. And similarly, also you can use the definition of if y at 2 comma 1. This will be also 16 using the same definition of the limit as was given in the week 1. So any path you can choose, but that will be also only lengthier. That's all.
Sir, how can we understand by seeing that limit exists?
Yeah, so that's a bit of bit through habit of doing solving questions. I mean, for example, here I told you no that this is a polynomial function in x and y. This is a like high dimension polynomial functions in x and y. So that's why I can tell the function will be differentiable. So that's why since the function is differentiable, both the partial derivative will exist. But if this is simply continuous, we cannot say, right? For example, if the function is given like this, uh, mod x plus mod y, then the function is continuous actually, but it's not necessarily imply that the partial derivative will exist at 0, 0. We all know that the partial derivative does not exist at 0, 0, right? So, okay, so let me do this example then. Okay, so find fx 0, 0 and fy 0, 0 if exist. So the function is given by mod x plus mod y. So now here we cannot guarantee, or we by seeing the function, I cannot say that if the partial derivative exists or not, because this is not a polynomial function, right? Because x square and y square, or maybe x cube, or maybe some higher power is not here. So that means I cannot just assume that the partial derivative exists. So in this case, we have to just go through the limit definition and have to check if the partial derivative exists or not. So let us check. So first, we're gonna go with this definition. So this is limit h tends to 0. This will be f of h comma 0 minus f of 0 comma 0 divided by h. So this will be limit h tends to 0. Now what is f of h comma 0? So this will be modulus of h plus 0 minus 0 divided by h. So this will be limit h tends to 0 mod h divided by h. So now you can see that this limit does not exist. Why this limit does not exist? So let me explain. So since now it's a one variable limit, right? Because this is 0. So now you can approach h from either right side or left side. So now if you are approaching from right side, then this limit is called right hand limit. So this will be modulus of h by h. Now since you are approaching from right side, this will imply h is greater than 0. Then mod h will be changed into simply h. So this limit will be 1. Now if we approach from the left side, then from this side h is less than 0. So it will be minus h by h, and it will be minus 1. Correct? So that means limit h tends to 0 plus mod h by h is not equals to limit h tends to 0 minus mod h by h. Correct? So this implying that limit h tends to 0 mod h by h does not exist. Okay? So from here we can say that if x 0 comma 0 does not exist. Similarly, also you can prove that if y 0 comma 0 does not exist. Okay, so I think this was helpful for you. Is it clear now?
Sir, can you one time scroll up, please?
Here.
Sir, the 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 DNE written above the diagram, how can you prove that does not exist? About the arrow diagram, the DNE does not exist. You have written that. How can you prove it, sir? How can, sir, explain one more?
Okay, so I just explained, right? What is mod x function? So mod x function is x when x is greater or equals to 0, and minus x when x is less than 0, right? So this looks like this. Correct. So this line is y equals to x, and this line is y equals to minus x, and the whole function is called y equals to mod x. So now here, if you take the right hand limit, which is h tends to 0 plus, so that means you are approaching from the right side. Now since this is 0, the left side is negative, right side is positive. So that means h is positive. Now h is positive imply this mod of h will be simply h. So that's why I have just replaced mod of h by h. Now h and h get cancelled out. You are left with only 1. Similarly, if you take h tends to 0 negative, h tends to 0 negative means h is less than 0. You are approaching from the left side, and left side is nothing but always less than 0. Correct? The left side of 0 is always negative. So that means mod of h is nothing but minus of h according to this definition. Correct? So then h and h got cancelled out and you are left with minus 1. So that means the right hand limit is plus 1 and the left hand limit is minus 1. So that means we can say that the limit does not exist. Is it clear?
Okay, sir, you explain. Yes, sir. Sir, you
Okay.
explained the before part about the diagram, written
Yeah,
DNA.
sorry, I didn't get your question.
Sir, did you explain the part about the diagram written DNA does not exist about the diagram you have written then?
Yeah, I explained, right? Already I explained.
Okay, that I had understood the down part, so I understood that same. Okay, sir.
Okay, fine. Yeah,
Understood, sir.
yeah, tell me.
So we use the variable h only when x tends to 0, right? Apart from that, when x tends to some number, we don't usually use the variable h, right?
Yeah, so variable h is always tends to 0 because of the fact that x minus a, sorry, x tends to a, and then h is replaced by x minus a, and since x is approaching a, this is approaching 0.
Okay, sir.
Okay, yeah. Okay, so yeah, let us go to the next question.
So,
So
or can we use h when if x tends to some other number, can we use h?
uh, if x is tending to another number, already in the definition we have h is replaced by x minus a. So it doesn't matter whatever a is, x minus a is always replaced by h, right? So h is a very
Okay.
small number that is tending to 0 always. I mean h is independent of x and a. I gave you the definition
Okay.
here, right? So you go through the definition once again. So you see here. So here this is the one dimension definition of differentiability of a function at the point A, correct? So what I did, irrespective of choices of x and a, I just approach it as h. Now as x varies, h will also vary. As x approaches a, h will approach 0. That's why this definition is changing to this definition. So these are equivalent definition.
Okay. Okay, sir.
Yeah. Okay. So yeah, I'm gonna go to the next question. This is a very interesting question. Okay. Everybody should listen this question. So yeah, find out the domain and range of f of x comma y equals to ln of y minus x. Okay. So now what is domain and what is range? That first we have to know. Then only we can say, I mean, we can find out the domain and range of function. So let me go to the one variable case. So for example, if a function is given from d to r, so r is the set of real numbers, and d is a subset of r, then we say d is domain where the function is defined. Okay, so in some cases the definition of domain is different. For example, in some book they define a domain to be open and connected. So this is sometimes they do like that. So I mean, but this is very restrictive. Okay, this is a very restrictive definition. But here we domain means the region where the function only is valid. The function takes only real value. Okay, real value. So now the range is nothing but uh, the range of f is nothing but f of x such that x belongs to the domain. Correct. So this was the definition of domain and range, right? So now, for example, if I give you the function f from R to R, or maybe yes, f from R to R by, sorry, yeah, let me write it clearly. F from R to R by f of x equals to ln of x. Then can you guys tell me what is the domain and range of this function? Anyone? This is a very basic question.
So domain is x greater than 0.
Yeah, that's true. Domain is x greater than 0. Why? Yeah, that's the correct answer, but why? Okay. So the graph of the logarithm function is nothing but this one, correct? So this point is 1 comma 0. So now from here we can see that these functions do not take any negative value, even the value 0. So that's why if you take any value which is less equals to 0, the logarithmic function is not defined, because the function is only defined for x strictly greater than 0, correct? So that's why the domain is x greater than 0. So that means the domain D is nothing but set of all point x in R such that x is greater than 0, or simply written like this, R plus plus. And the range is nothing but whole real number system, because you see the function is going from minus infinity to plus infinity. So it will cover all the values in the real number. Okay, so that's why the range of f is the set of whole real numbers, correct? So this is the definition of domain and range. Okay, so now here okay, so now here we have to find out the values for which this ln of y minus x is finite, right? So now we can see that ln of y minus x is valid, I mean is real, if y minus x is greater than 0. So if you take any other values such that y minus x is less than 0 or y equals to x, the logarithm will does not exist. I mean, the logarithm function does not exist because it takes only positive real values, right? So that means the domain is nothing but x comma y in R2 such that y minus x is greater than 0. In other words, x and y in R2 such that y is greater than x. Okay, so this is the domain. What about range? So what is the range? So now one thing to see, the function f from R2 to R. So clearly range of f will be subset of R. Okay, so now if you can show that any point in real number has a pre-image in R2, then we can definitely say that the function has a range whole of R, correct? So what I mean by that? So I mean by that is that I want to show that range of f is R. Now suppose if there is two set A and B, where A is subset of B and B is subset of A, so this will imply A equals to B. Now see here A subset of B is given, so range of F is subset of R given. But if we can show that the R is also subset of range of F, then only we can say range of F is equals to R. So that means given a point in the real number, I have to show there exists x0 and y0 in R2 such that f of x0 comma y0 is ln of sorry, f of x0 comma y0 is alpha, correct? So I have to find out a point in the in R2 such that this holds. Now this we can do by solving the equation, this equation. So what is f of x0 comma y0? So this is nothing but ln of x0 minus y0. and this is nothing but x0 minus y0 equals to exponential exponential alpha, and this is nothing but x0 equals to y0 plus e to the power alpha. So now you choose any x0 comma y0. For example, I can take x0 to be 1, then y0 will be nothing but 1 plus e to the power alpha. Then the image of 1 plus 1 comma 1 plus e to the power alpha is nothing but alpha. So that means for this element on the codomain, I have found out a pre-image which always exists in R2. So then you can say that alpha belongs to R is implying alpha in range of F. So this is implying R is subset of range of F. And we have already shown that range of F is subset of R. So this is implying range of F is R. Is it clear? I
Sir,
went,
can you one time
yeah,
Sir, one time you can explain from ln x naught minus y naught equal to alpha. How do you wrote that from there?
yeah. So basically, to show that every number in the real number system has a pre-image for this function, we have to show that there exists a point x0 comma y0 such that f of x0 comma y0 is alpha, right? That's what we have to show, correct? Like up to this point, is it clear or not?
Up to that point it is clear, but
Okay,
how do you
okay.
rewrite ln
Yeah,
x naught minus y naught equal to alpha?
yeah, because what is f of x comma y? F of x comma y is ln of y minus x, right? So I'm just replacing x and y by x0 and y0. Because f of x0 comma y0 we can always write, right?
Sir, not got, sir. How do you write that?
Okay, so you take point x0 and y0 such that it is positive. You get the point. So you take, for example, I'm saying that f of x comma y is ln of y minus x. So you take 2 point x comma y such that ln of x0 minus y0 is alpha. So that means you can find out x0 and y0. For example, from here it will be x0 minus y0 equals to exponential alpha. So x0 will be nothing but y0 plus exponential alpha. Correct. So this is just basically solving equations, right? Is it clear? This is very easy, right? This is you just, this is you just solve the equation, right? I'm just solving the equation only, right? Since you just replace f of x0 comma y0 by ln of x0 minus y0. So it doesn't matter if it's in the domain or not. It will be eventually in the domain because we have found out the points x0 and y0, right? For example, here you see y0 is strictly greater than x0. Correct. So that means indeed this point x0 and y0 belongs to the domain. Is it clear for you or not? You can tell me the exact point where you are getting difficulties.
Sir, no, one more time you can explain ln x naught minus y not equal to alpha. How do you wrote that?
So what is the before line? I mean, what is the line I have written before that? I have written f of x0 comma y0 is alpha, right?
Yes, sir.
And what is f of x0 comma y0? What is f of x comma y? Yeah, can you tell me what is f of x comma y?
Sir, value.
Yeah, sorry. F of x comma y is what? F of x comma y is ln of y minus x, right?
Yes, sir. Yes, sir.
Then what is f of x naught comma y naught?
ln of y naught comma.
Y naught minus x naught. This is what I have
Okay, it
written
is
as.
given. Oh, it is given, sir. Is it given?
Yeah, it is given. No, I have written in the
Okay, sir.
question.
Understood, sir. Understood.
Okay, fine. So yeah. Okay, so Okay, so this is the next question. So this was
Sir,
question
can
number.
you scroll up one time, please?
Yeah. So these slides will be available. Don't worry about it. And the videos will be also available in the YouTube. So I'll upload these videos in the channel, so you guys can go and see the videos also. Okay, don't worry about it.
Sir, sir, how do you wrote alpha over there? F of 1 comma 1 plus e raised power alpha equal to alpha.
Yeah, because this is how we find out x0 and y0, right? Because I took x0 equals to 1, and then I mean, sorry, I took y0 equals to 1, and sorry, so this will be, yeah, this will be then, so this will be y0, not x0, and this will be x0. Yeah, so this will be, no, it was all right, right? Sorry, this is okay. Yeah, yeah, this is the point. Y0 equals to 1 and x0 equals to 1 plus e to the power alpha.
Sir, alpha value, how did you know? How do you know that it belongs to R?
Wait. So from here, y0 will be x0 minus e to the power alpha. Sorry, this will be x0 minus e to the power alpha. So if you take x0 to be 1, then y0 will be 1 minus e to the power alpha. So then f of 1 comma 1 minus e to the power alpha will be alpha. Yeah, this will be the equation. Now is it clear? So I wrote it, I mean, here it should have been x0 minus e to the power alpha, not plus, because the y0 will be going to the right side and then e to the power alpha will be coming to the left side. So y0 will be x0 minus e to the power alpha. So now you just take any values of x0 such as 1 here. Then y0 will be nothing but 1 minus e to the power alpha.
Sir, can you just write and show please one more time how it is equal to alpha?
Okay, you take here, no? So this was, what was the function? So this will be y0 minus x0, because this is, okay, so now it is there. Yeah, so now can you see? So I have written wrongly here, right? I mean, this will be y0 minus x0, right? The function is given as ln of y minus x. So yeah, this will be ln of y0 minus x0 equals to alpha. And then y0 minus x0 is e to the power alpha. And then y0 will be x0 plus e to the power alpha. So if you take z just x0 equals to 1, then y0 will be 1 plus e to the power alpha. So f of 1 comma 1 plus e to the power alpha will be alpha. So now you want to see how it's coming. So ln of y minus x is nothing but ln of 1 plus e to the power alpha minus 1. So it will be ln of e to the power alpha, and this will be alpha. Okay. So yeah. So this is the solution. Is it clear?
Yes, sir, clear.
Okay. Yeah. So I did a mistake here. So it should have been y0 minus x0, not x0 minus y0. Okay. So yeah, next question I'm gonna go. Question number 4. Let
Sir, can
f
you
of,
one time scroll up, please?
yeah,
Sir, how can you write that alpha belongs to Rn?
alpha belongs to what?
Alpha belongs to real numbers.
Yeah, because that's where we have to show, no? That we have to show the range is R. Because we have already shown that range is subset of R. Now we have to show that R is subset of range of F. Now, for example, if you want to show A is subset of B, then what are you gonna do? You're gonna take elements from A, and then you will show that this belongs to B. So that's why I chose a number from range of F, and then I showed that it belongs to R. Sorry, I took a number from R, and then I showed that it belongs to the range of F. So that will imply R subset of range of F. Is it clear, or I'll go to the next question?
Yes, clear, sir. Sir, how can you write R is less than equal to range F?
Not less equals to, this is subset. This is not
Sir,
the,
understood, sir. Yes, sir.
So this is called less equals to, this is called subset. Okay, maybe my
Sorry,
handwriting is
sir.
bad, that's why. So
Yes.
this is called less
Sorry,
equals
sir.
to, and this is subset. Okay. So this is less equals
Sorry,
to,
understood, sir. Understood.
okay, less or equal, and this is subset. Okay, so if there is two set A and B, then A subset of B, and if there is two real number A and B in R, then A is less equals to B. These are the notations we use generally. Okay, so I'm going to go to the next question. So yeah, let f of x comma y is sin x plus y square. Then if alpha fx of 0 comma 3 plus fy of 0 comma 3 equals to f of 0 comma 3, then find out okay. So yeah, so anyone any guess? So first we have to find out the partial derivative with respect to x. So this will be nothing but cos x plus 0. So this will be cos x. And what is fy of x comma y? So this will be 2y. So this is 2. So fx of 0 comma 3 will be this is what? This will be cos of 0. So 1, and fy of 0 comma 3 will be 2. So alpha into 1 plus 2 equals to what is f of 0 comma 3? F of 0 comma 3 is nothing but 9. So alpha is, so am I doing correctly or not? So this will be 2y. Okay. So yeah, this will be 6. So this will be, so it is given that alpha fx of 0 comma 3 plus fy of 0 comma 3 is f of 0 comma 3. So you now substitute all the values. So this will be alpha into 1 plus
It was
6.
three.
Yeah, tell me.
Answer is three. Three. Answer is three.
Yeah, answer is 3. Yeah. So this is implying alpha is 3. Okay. Yeah, thank you. So yeah, this is the answer. So I think this is pretty easy. Okay, so now we are going to the next definition. I think that has been taught in this week. This is nothing but the continuity.
Sir, can you one time scroll up, please?
Scroll up. Okay, is it okay?
Sir, more up, please.
More up here.
Sir, how you can write alpha f of x 0, 3? Sir, it is given. Okay, sir, it is given. Okay, sir, got.
Okay, so so next question. This is a very interesting question actually. So okay, so now first I have to explain continuity. So what is continuity? So in one variable, we have seen that if function is given from R to R, then we say the function is continuous. Sorry, if is continuous at x equals to c, if limit x tends to c, f of x equals to fc. So now this is almost same as the definition of limit of a function. where the limit is nothing but f of c. Correct. So the definition of limit was like this: limit x tends to c, f of x equals to x L. Now if this L exists and finite, then we can say that the limit of the function at the point c exists. But now if this L is equals to f of c, then we can say the function is continuous. Correct. Now in case of two variable, the limit, the definition is almost same. So now we say that this function is continuous at the point a comma b if this is equals to f of a comma b. Correct. So this is called the definition of continuity. Now the epsilon delta definition is also same, that given epsilon greater than 0, there exists delta greater than 0 such that square root of x minus a square plus y minus b square less than delta will imply f of x comma y minus f of a comma b less than epsilon. Okay, so this is the epsilon delta definition. I think you all guys are aware of it, right? This is a simple definition. So yeah, I'm gonna solve some questions here. So question number, uh, let me write one. So let f of x comma y equals to exponential x into tan inverse y by y, where x comma y is not equals to 0 comma 0 and k, where x comma y is 0 comma 0. Okay, so now they are asking the question, what is the value of k if f is continuous at 0 comma 0. Okay, so now what is the definition of continuity? So we just wrote that if the function is continuous at 0 comma 0, then this will be nothing but limit x y tends to 0 comma 0, f of x comma y equals to f of 0 comma 0, right? So now in the question it is given that f of 0 comma 0 is k. So we have to just find out the limit of this function, right? So what is limit x y tends to 0 comma 0 f of x comma y? So this is x comma y tends to 0 comma 0 f of x comma y. So this is same as limit x comma y tends to 0 comma 0 exponential of x tan inverse y divided by y. So now there is one thing to remember actually. So it says that, so I'm going to write as a theorem. So if f of x comma y is g of x into h of y, and limit x tends to a g of x comma limit y tends to b h of y exist, then limit xy tends to a comma b f of x comma y, this will be same as limit x tends to a g of x limit y tends to b h of y. So I'm going to use this theorem. Okay, so I'm going to use this theorem. So now here we can see that f of x comma y equals to exponential x into tan inverse y divided by y is nothing but exponential of x into tan inverse y of y by y. So that means our g of x is nothing but exponential x and h of y is nothing but tan inverse y divided by y. Correct. So by using the above theorem, limit xy tends to 0 comma 0, fxy is nothing but limit x tends to 0, exponential of x, and limit y tends to 0, tan inverse of y by y. Since both the limit exist, so that's why I can write this limit separately. Correct. Now what is this limit? So this limit is nothing but e to the power 0 multiplied by limit y tends to 0, tan inverse y by y. So now can anyone tell me what is the limit of this? Limit y tends to 0.
Sir, tan inverse y upon y is 1.
Yes, but why? How did you find out?
Sir, I know. Sir.
I mean, yeah, I understand you know, but how do you know? That's the question. Okay, so here you can use L'Hopital rule. So for example, you see if you just put y equals to 0, so this is a 0 by 0 form. Correct. So by L'Hopital rule, so you can do the derivative and the limit will be still equal. So this will be 1 by 1 plus y square divided by 1. Correct. And this is nothing but 1 by 1 plus y square, and this is 1. So that means this limit is 1. So limit xy tends to 0, 0, f of x comma y is 1, and this was equals to f of 0 comma 0, and this was equals to k. So if the function is continuous, k has to be equals to 1. So this is the answer. Yeah. Any questions so far?
Sir, in the question,
Yeah, tell me. Hello. Can you hear me?
sir, in the question, they asked the k value for some other point only, no, sir?
No, k was they asked the question for 0 comma 0, right?
No, not here.
Mm, yeah, this is 0
But
comma 0, right?
what what you wrote over there, sir? F is else at
Sorry, I didn't get your question. They asked that if f is continuous at 0 comma 0, then what is the
if
value of
f
k?
is else at means apart from 0 comma 0 they are asking the k value, right, sir?
Yeah, so they are asking if the function become continuous at 0 comma 0, then what the value should be replaced in place of k?
So one second. Sir, can you repeat the question?
Yeah, so basically they have given you a function. Okay, so at the point 0 comma 0, they have given an arbitrary value which is k, which you don't know. Now they are asking if the function become continuous at 0 comma 0, then what will be the value of k? Correct. So to proceed that, we just find out the, like we use the definition of continuity at the point 0 comma 0, and then we find out that the limit x comma y tends to 0 comma 0, f of x comma y is nothing but 1. Now since if it is continuous, it has to be equals to f of 0 comma 0, and which is nothing but k. So that means k has to be equal to 1. Okay, yeah, I think he got
Sir,
disconnected.
Sir, but
sir.
sir, how do you find say that the limit is continuity?
No. The limit.
The
So
question is continuity.
because I told you, no, they're asking the question that if f is continuous. So the question is if f is continuous at 0, 0, then they're asking what is k. Okay. So what is the definition of continuity? So the
Oh,
definition of
the
continu
ELS means continuous.
yes, not ELS, CTS.
Okay, sir. Okay, sir. Okay, clear, sir.
Okay. CTS means continuous. I'm sorry, actually writing I'm CTS.
Okay, okay.
Okay, yeah. CTS means continuous. Okay.
Sir,
Yeah, tell me.
sir, how can we understand that the first part is trending to zero?
I wrote the theorem for that, no? This theorem. So if the function is separable, then you can separate the limit with respect to x and y when both the limit exist separately. That's what is the theorem.
Sir, how can you know that both the limits exist?
Yeah,
First limit exists.
because I find out just now that both the limit exist. Because from here I can write only because I know that both the limit exist. Because limit extends to 0, exponential x we know exist, right? And also we know that limit y tends to 0, tan inverse by y exists. So that's why I can separate. And they are also written separately, right? I mean, they are separable because f of x comma y is written like exponential x into tan inverse y of y. That means it's a product of two different function in two different argument. So it's a product of function in x argument multiplied by y argument. And this is not always possible. This is a special case. For example, if I give you f of x comma y equals to sine xy by x square plus y square, then you cannot write this function as f of x into, I mean, sorry, not f of x, g of x into h of y. Correct? Is it possible? No, right? Hopefully this is no. So since it was possible, so that's why you use the separable limit of each of this function. And since it exists, we can write separately.
So one thing, the like the sample question you have provided that for implicit functions. So if it is mentioned like function is continuous and the limit exists, so in that case we can calculate the limit by any single path, and then we can find out the value of k, right?
Yes, if it says that limit exists, then only.
Yeah. Okay.
Yeah, definitely, obviously. If the limit exists along any path, the limit should be equal. Then you find out the like easiest path and then find out the limit. That's all. Okay. So yeah. So we're gonna go to the next question if there is no doubt again. Okay, so I'm gonna use the polar coordinates for this time, and I will show. So, for example, this is another question. Uh, let f of x comma y equals to xy multiplied by where x and y are non-zero and 0 when x comma y equals to 0 comma 0, right? Okay, so now they're asking that examine the continuity of f at 0 comma 0. So first I'm gonna go with the usual approach, the Cartesian coordinate approach, and then I'm gonna go with the polar coordinate approach. Okay, so first of all, try to see that this the in the numerator the power of the variables, like summing power of the variables of x and y, are much higher much higher than the denominator. So for example, here you can see this is 1 plus 1 2, and here it is only 2. So 2 plus 2 4 higher power is there in the numerator than in the denominator. So we can assume that the functional value will go to 0, right? Because the denominator power can get cancelled out at some point, and then the numerator power will be very much higher. So then if we just put the values of x and y, which is 0, 0, the functional value will be 0. So that means we'll show that for any epsilon greater than 0, there exists delta greater than 0, such that 0 less than square root of x squared plus y squared less than delta will imply this holds. Okay, so we're going to start with this one. So this will be modulus of xy into x square minus y square by x square plus y square. So now this is nothing but mod x mod y into modulus of x square minus y square by x square plus y square. Correct. So now try to see that x square minus y square is always less equals to x square plus y square. So that means x square minus y square divided by x square plus y square will be always less equals to 1. So this will be less equals to mod x into mod y. And we all know that mod x is nothing but square root of x square plus y square, and mod y is also less equals to square root of x square plus y square. So this is less equals to x square plus y square. Okay. So now what do we have to show? We have to show that this is less than epsilon. Okay, so this is less than epsilon, and this is implying that square root of x square plus y square is less than square root of epsilon. So if you just take delta equals to square root of epsilon, then modulus of f of x comma y minus 0 less than epsilon will hold whenever square root of x square plus y square is less than delta. Okay, so is this clear in the definition of Cartesian coordinate? Otherwise, I'm gonna go to the polar coordinate.
Sir, can you one time explain the, sir, can you scroll up one time? Sir, can you explain that epsilon greater than 0, delta greater than 0 with respect to the question?
Sorry, I'm not getting your question. What do you mean by x greater than 0? This is the definition, right? That given epsilon greater than 0, there exists a delta greater than 0 such that this will hold. That's I explained in the beginning, right?
Okay, sir. So can you explain from there?
Okay, so yeah, this is for the last time I'm explaining, and first and last time. So this is so basically we have to show that this holds modulus of f of x comma y minus 0 less than epsilon. So then we can find out the values of delta. So here f of x comma y is nothing but xy multiplied by x square minus y square divided by x square plus y square. So I have just replaced the value here. So this is nothing but mod x into mod y into modulus of yeah. Can you guys hear me? Hello.
Yes,
Yes.
sir.
Yeah, I lost connection. There is some problem, I think. Okay, I'm sorry for that. Yeah. So yeah, can you see now?
Yes, sir.
Okay, yeah. So we have to show that f of x comma y minus 0 is less than epsilon. Okay, so that's why I have just replaced the function with the value xy into x square minus y square divided by x square plus y square. So this is nothing but mod x into mod y into mod of x square minus y square divided by x square plus y square. Correct. So now we know that x square minus y square divided by x square plus y square is less equals to 1. So this will be less equals to mod x into mod y. Now again we know that mod x is less equals to square root of x square plus y square. Similarly for mod y. So that means it will be less equals to no, so this will be less equals to, sorry. Yeah, so this will be less equal to x square plus y square. Yeah, because this is mod of x square plus y square into mod of x square plus y square. I mean, so then the square root get cancelled out. It will be only simply x square plus y square. So this is x square plus y square. So now we have to show that this is less than epsilon, correct? But we have to show that this holds. So to make it happen, we have to just take square root of x square plus y square less than epsilon. So that means root epsilon. So that means delta is nothing but root epsilon. Is it clear now?